We all know that fruits and vegetables are part of a healthy diet. We're mostly city folk and hear that we should shop local and avoid processed food. Many are also concerned about climate change impacts on the supply and quality of our food, water, and environment. But how much of what we've heard is actually true? Well, we know that to meet increasing demand for these nutritious foods, supply chains must be sustainable. For the most part, producers have so far been able to adapt to changing environments and extreme weather events like droughts and floods. But what about the future? With funding from USDA's National Institute for Food and Agriculture, we've assembled a unique, multidisciplinary research team to explore climate adaptation and mitigation opportunities for U.S. fruits and vegetables. We're developing and applying a new integrated assessment framework that includes crop, economic, and environmental or life cycle assessment models.
My task is to use statistical models to model crop response, fruit and vegetable response using the historical data, and then try to understand their future response and predict their crop yield on the future conditions. And
my role on the project is to develop the life cycle assessment, that is to calculate the carbon, water, energy, and other environmental consequences of the production of the fruits and vegetables that we're studying.
I have two roles in this project. One is on the extension piece for the Washington and Pacific Northwest area, and the second is in the water modeling piece, specifically looking at irrigation water availability for fruit and veg production.
Crop modeling is like doing an experiment in the field where we do it on the computer, where we try to understand how a crop behaves under current climate and how it might change when we then apply climate change scenarios onto these crops in the future.
The first crops we've studied are potatoes and tomatoes when eaten as chips, fries, ketchup, and pasta sauce. We already have many interesting findings. Except for Southern California, water availability is unlikely to constrain future production. Major efficiency improvements are expected due to better irrigation technologies and crop response to higher CO2. Secondly, barring extreme weather, climate impacts will be relatively minor, primarily as a result of adaptation by shifting planting dates. However, a decline in nutritional value is anticipated. Moderate land use changes for production of these crops will continue, with opportunities to expand production in higher yielding areas of the Pacific Northwest, as well as lower yielding winter production areas in the Southeast. Finally, life cycle assessment modeling reveals surprisingly high environmental impacts for processing and consumption, with crop production occupying a relatively small part of the overall carbon footprint. These findings have major implications for prioritizing hotspot opportunities in potato and tomato supply chains. For instance, mitigating emissions beyond the farm gate in processing, retail, preparation, and consumption might be more effective than altering field production. Our unique integrated modeling methodology can be applied to examine the many other specialty crops needed for a balanced diet. That would help identify what's needed to conserve key resources and help producers and processors efficiently adapt to the challenges of accelerating climate and water availability changes. As part of our USDA-funded project, our team is currently investigating other crops, including carrots, green beans, oranges, spinach, strawberries, and sweet corn, and we hope to add to this list in the future.